Hey, Snackers, this is Kareem Iskander.
Hey everyone, Matt DiNapoli here.
Welcome to episode 193 of Snack Minute.
Kareem, we teased this episode last time, and we brought it to bear. So, Snackers, we have a longtime contributor, Joe Clarke, joining us today, and he's going to talk to us about some really cool stuff being added to CML. So, Joe, for the newbies, if there are any newbies after 193 episodes, please introduce yourself, and then we'll jump right into it.
Sure, yeah. Hi, my name is Joe Clarke. I am a distinguished engineer in our Learn with Cisco group. At Cisco, I work very closely, amongst other things, with the Cisco Modeling Labs team. If you're not familiar with Cisco Modeling Labs, you will be at the end of this, but in essence, it is a way to create virtual topologies for testing and learning and all sorts of fun stuff with networking.
I thought Joe was gonna say if you don't know what Cisco Modeling Lab is, you're dead to me. That's what I was going to follow it up with.
I mean, maybe that might be true, but he's being nice to our snackers here. I mean, Kareem and I have been talking about MCP servers for like the last, at least, I don't know, 10 episodes, or in some way, shape, or form for the last 3 or 4 months. It's the current hotness in the AI space, and we're actually seeing some really practical use of it, which is really exciting in the practitioner space that we're working in. But Joe, can you start to talk about what we're looking at adding in, or if we've even added in yet? I don't know. This is all going to be news to me with MCP services into CML.
Sure. Oh, the fact that you've already talked a lot about MCP saves me a lot of time. I had dinner with one of our CTOs a while back, and he said everyone should be writing MCP servers right now. So good, that's out of the way. What MCP and CML? No, it isn't a formal thing yet, meaning it isn't part of the product. I demoed it to the product team this morning. What you're going to see here is in GitHub. You can play with it today. It's free to play. And it works with things like Claude Desktop and LM Studio.
Oh, wonderful.
I'm going to demo it with Claude, but I also play with LM Studio in the GPT open source model. It works very well there too.
Yeah, we've had Kareem, who was on that showed us LM?
We had Jason Balcon.
Oh, Jason
talk about LM Studio, and we're actually having another episode here shortly with Hank Preston to talk more about and dive into LM Studio. So
okay, that's great. Yeah, and that's
a great for that.
Yeah, it's a great learning tool. So, but Kareem's always shows us Claude as well. So we have the context for our snackers ready to go, Joe.
Okay, so let's say you want to play with CML, but your mouse wrist hurts and you don't want to have to drag and drop things around the screen. What do you got to do? Well, this is where MCP comes in. MCP with the large language model. In this case, we're going to be using Claude 4 Sonnet. We can just chat at our CML server and get it to do fun and crazy and stupid CML tricks. So you can see all of these CML tools here. I didn't create or pass the whole API, whole REST API into MCP. I focused on some tasks that you might like to do. And so you can do things like, tell me how many nodes can I run at once on CML? And so what it'll do is it'll start to call these tools. And since all your snackers know what MCP is, the concept of a tool isn't foreign to them. But essentially these functions, this is all written in Python. We'll glance at the code in a bit. It's going to get system information. It's going to get some license information. And then based on the total number of licenses that I have on my server, it will say you could have run up to 520 nodes, but there's some practical considerations, like if you don't have that many CPU cores, you don't have that much memory. So consider that. Like, okay, well, that sounds like a good way to get started, but let's create a new lab. Let's see what I have a few nodes I can run, so I'll just try to create something. So I'll say create something called Joe's new lab on my CML server. Again, just chatting with it. Again, it says, okay, I'm going to think about this. I need to call a tool called create an empty lab. If I come back over here to my CML server, you can see Joe's new lab just appeared. So we now have a new empty lab, a box that can contain stuff. That's not all that terribly interesting. So let's add something to it. And let's say add 2 IOL nodes, an unmanaged switch, and an external connector. I'm not being very prescriptive. I'm not saying these are the exact node definitions I need you to do, like the IDs of them. But what it's going to do is figure out what all the node definitions are available on the server and figure, oh, you said you wanted me to add 2 IOL nodes. Well, let me add 2 IOL XE router nodes. Okay, that seems reasonable. We'll add an unmanaged switch. So we figured out what the ID for that is, external connector. So we'll add these 4 nodes. And again, it summarizes what it did for me. And let's take a look. Did it actually do it? Looks like we got 4 new nodes in CML. Looks like what we wanted. 2 IOL routers, a switch. Looks like it's an unmanaged switch. That's great. And an external connector. Fantastic. Still not terribly interesting because there's nothing these things are doing. So let's build a topology now. I'll say, Claude, connect these 2 IOL nodes to the unmanaged switch and connect the unmanaged switch to the external connector. So in order to do that, it needs to figure out, okay, what interfaces do I have available to me? I didn't say what interfaces I wanted it. You figure it out. You make the best judgment. I could have said, I want these connected on these interfaces. That's fine. It would have done that, but I'm letting it be a little bit creative. So it figures out the interfaces and it says, you know what, I'm going to use Ethernet 00 to this port on the switch, this same Ethernet 00 on the second router to that port, and then this port to the external connector, and then it will start to connect these up. And you can see it's adding the links, the interfaces. Fantastic. That's great. Looks like what I wanted. Come back over here to the summary. And it even built me a nice little ASCII art representation of that topology. And that generally looks like what we got. Now, here's where things get really fun. So we've got a topology, but it's not really doing anything. So let's tell Claude, I want you to configure these routers so that their connected interfaces have a specific IP address. Configure OSPF on them. I didn't tell it how to configure OSPF. I didn't tell it what I really wanted. Just give me some OSPF working and then start the lab and validate that OSPF is working correctly. So this is going to involve several tools. So first of all, it's got to configure the nodes. It's going to configure a basic OSPF or IP addressing and OSPF topology or configuration on router 1. It's going to do the same thing with router 2. Then it's going to start the lab. And I added the capability in there to wait for the lab to fully converge. I didn't tell Claude, hey, I want you to wait for the lab to fully come up. It figured, you're asking me to validate if OSPF is working correctly, so maybe I need to wait for the lab to be ready. So, okay, it started it. And now what it's going to do is use the pyATS interface. So pyATS, automated testing system written in Python. CML integrates with it, and it allows us to run exec level like show commands and configuration commands on running nodes through their consoles in CML. So the first thing it's going to do is just try to figure out, what is the status of our OSPF neighbor on router 1. So it's going to send to router 1, run the show IP OSPF neighbor command, and it gets the output. And it sees that we're not quite converged yet. So it says we're in two-way DR other state. We should be in full state because, Joe, you asked me, is OSPF verify OSPF is working correctly. We come back over to our topology. We see everything is started. I can bring up the console on one of these nodes, and you can see pyATS is just happily running, or Claude through the MCP server with pyATS is happily running these commands. It's validating things like ping reachability. It's just doing all this reasoning, part of the React agentic flow to try to figure out, okay, give me all the data I can, and then let me check and see what the ultimate result is. So the reason why it didn't come up initially correct is it just has to wait for convergence time. So Claude isn't really waiting for that. It keeps testing things, but ultimately it does validate that everything is working correctly because after all the commands it ran, the convergence is there, and we see, oh, look, we've got the IP addresses were configured correctly. Process 1 and area 0 looks good. We've established neighbor adjacencies. It says we're in two-way other, but it says it's still coming up. And I can ask it, like, check again to see if OSPF is full. And you can see, we'll watch in the background here, it'll start to interact with the console again. It's going to run probably the show IP OSPF neighbor command. There it is, and it says full DR. So what this is saying is router 2, router with the ID 22222 is in a full state, and it is the designated router. So it's also going to do this on router 2. So it does it on router 2, and it sees that we are router 1 is the backup designated router, and it summarizes all that. So great, we've got OSPF working correctly. This is fantastic. Now I just want to make this a little bit prettier, so I can tell Claude, hey, why don't you create a box around these two IOL nodes to indicate they speak OSPF, and make it green because I like the color green. So another tool I added was this ability to create annotations. There is no such thing as a box annotation. So Claude figures out that I meant a rectangle. And not only did I mean a rectangle, it also thought it would be nice if it included text that said, I didn't tell it to put the text. I said that this box would just indicate that these routers run OSPF. It decided to be nice and say, I'll add some text. I'll add another annotation that says you want it to read OSPF area 0, which is in fact what these routers are running. Great, it did everything I want. I got everything good. You've done a lot of work, Claude. Now I want you to delete it.
Is Claude going to get sad after all the work that it's done?
I'm going to get sad after all the work.
It might. The way it gets sad, and I'll show you this code in a second. We have to be very careful with MCP. So this was all the whiz bang, the fun, the exciting part. MCP, if we're giving LLMs access to our systems, in this case CML, but Kareem, I know you've done some great work at integrating various things with MCP. If we give too much access without enough protection or security, the LLM is just going to call tools. It don't care. It's going to call them, and things can happen. There are ways to hint at the MCP server that, hey, in the MCP server to the client, that this is a destructive thing, or there's a system called elicitation. We can ask for prompting, but not all the clients support that. So be a little careful. Now you notice it is telling me before I delete the lab, I absolutely want to make sure you're okay if I delete Joe's new lab, because it will permanently remove the lab configuration nodes and topology. It's waiting for me to respond. You can see here the lab is still there. This is something that I recommend everyone do, and I'll show you this in a second. I'll say, yep, I'm good with it. So now what we're going to see is it's going to start to shut things down. Then it will start to delete things, and then eventually the lab should go away. So yep, they're shutting it down. Boom. Lab is gone.
In our last episode, I was saying to Kareem, I think about these things like super junior engineers, and you kind of got to hold their hand through the process, which, first of all, watching this set up the lab and do all that work was awesome. But you were talking about the guardrail situation. If you were talking to a junior engineer and you asked them to remove something, I mean, how many times over the course of our careers have we encountered a situation where maybe we did it or someone else has done it that we've worked with, where they've pushed a configuration that was not right and not tested, or deleted a database or something destructive, and we didn't say to them, make sure to not delete the database.
Yeah.
And that's kind of what we're doing here, which is kind of cool. I'm glad you're calling out that opportunity for challenge that we could be running into in dealing with these tools, because even though there is some thought going into the activity that's going on, it doesn't always know the context of the thought. And so those things, I think, are good to tell our snackers, hey, this magic is pretty magic, but we got to be sure that we're not deleting things that aren't supposed to be deleted.
Exactly. And some of the ways you can add protections to your MCP server. I use FastMCP2 to write this. I think, Kareem, you've been talking about that. It has this metadata where you could say certain things are destructive. Some MCP clients might use that to ask for confirmation. There's also this notion of elicitation, which is part of the protocol, but again, not supported everywhere. But docstrings matter with MCP servers. This docstring is going to get passed to the LLM that teaches the LLM what a tool can do, what kind of input it takes. There are other ways for the input, but it teaches it what the tool can do. And you can insert something like this that says, before running this tool that will delete the lab, I want you to ask the user if they're sure they want to do it and wait for a response. The wait for a response was critical. The first time I did this, I didn't have that. And one of the instances just said, I asked, and then I went and deleted it. Didn't care. I asked you, but you didn't say to wait for a response. So think about these things when you're designing the MCP server. Think about the doc string. Make it rich, but don't go too crazy because that can eat up your tokens in your context window. And the other thing, the other bit of advice I will give is make sure you strongly type everything. So you see here, this is just taking an ID, but if I create empty lab, you could see that I have these types here. This is Python, so these are pydantic data types that are very well structured because part of the MCP protocol passes the schema of your input and your output as JSON schema to the MCP client. So the LLMs, the models, the applications, they're beginning to use that to really understand what the data is, what the input should be, and why that input is important, so that it can generally call the tool right the first time with the input that it expects. So those are some cool things to consider. Like I said, all of this code is out there in GitHub. You can play with this today if you've got CML. Even if you've got CML free, the free edition with 5 nodes, this MCP server can work with that too. You have that API, you can have these tools, you can see how you can interact in a very natural way with your Cisco Modeling Labs.
There's also the not only the input, which is really, really important, what Joe touches on here, for the model to understand your intention, but also the output, especially the error. So it's important to give that error to the model for it to self remediate what's happening. And I saw
Absolutely.
I saw you doing that, Joe, and we just wanted to make sure we highlight that because it's also as important as the input.
Because this is a REST API, oftentimes the HTTP error response, to Kareem's point, is going to have more the error, the exception itself will just be like, not found exception or something like that, 404, but the text may say, this is, or a 400 error, general like client gave bad input, but the actual text is going to say, I was expecting X, Y, and Z. And then to Kareem, your point, it's going to then the LLM will self-correct.
So we're calling out a couple of things here that I think can fall into 2 camps. So I just want to comment on them for our snackers here. You guys are talking about mainly considerations for creating these MCP servers, but I think we also have to think about the scenario where we're leveraging them and we haven't built them. So there is, I think we're in this new state of all these MCP services are being created. We're starting to consume them. And this is a little different than leveraging an API because the API is very dictatorial in how we interact with it. It won't work if we don't get it right. And with these MCP services, they may work in some way, even if our prompt isn't exactly correct. And to Joe's point earlier about trying to understand, or he ran into the situation where the labs were just deleting when he wasn't calling them out specifically by ID or name. When you start to use these services, especially if you haven't written them, I would say test them out very thoroughly in an environment that you could delete the lab in before you get into that notion of it. That being said, this is really freaking cool. And it was really fun to check that out. Joe, before we let you go, is there anything else you wanted to show us?
Not show, but I'll echo what you said there, Matt. I did this in Claude because Claude allows me to say always allow a tool to run, but by default it will prompt you. In fact, Cisco has an enterprise policy for our cursor, which we're allowed to use internally, and that policy is all tools must be explicitly tapped every execution. And before you do that, you could see this is the request I'm going to make, this is the input I'm going to provide. So I absolutely agree. Check, double check, make sure before a tool runs, you know what it's going to do, so it doesn't do something that surprises you.
There's also one thing I want to add to that, and I think I'll have Kyle come on to discuss this. But just like anything that's released out there, especially that's new, there are malicious MCP servers out there. So this is something that we gotta, just because it's an MCP server that satisfies your use case, you gotta make sure that it's coming from a trusted source.
Absolutely.
And that's really important because they can easily get information out of your data that they care about. And that's really, really important thing to highlight here for all of our staff.
Yeah, and diving into that, Kareem, for our snackers would be a really, really good idea.
Yeah.
Unfortunately, I mean, really, unfortunately, that's all the time we have today, Joe. Thank you for showing us this.
My pleasure.
Snackers, go check out the CML MCP project on GitHub, and start to play around with it and have some fun.
And give me feedback.
Yes,
We will. I know I'm going to integrate it.
If there's a tool that you want in there, and it's not there, let me know. I'm happy to keep coding.
Sounds good. Thank you, Joe.
Thanks.
Thank you, Snackers.